This is still section 5.3, and we're going to be taking a look at two more of the 5 classic chemical reactions. So just to remind you what we did last time is we took a look at a combination reaction where we're taking two things and we're combining them into one. We also took a look at the reverse reaction where we're taking one substance and it becomes two or more substances. So they're decomposing or falling apart. Then we took a look at what's called a single replacement, and that's when an element is going to be switching places with another element in another compound, which has multiple elements in it. So the magnesium switches with the hydrogen and it kicks it out and we get a switching. Now we're going to be looking at another replacement reaction right now, but it's not a single replacement, it's called a double replacement. So this is a double replacement reaction, and it's similar to the single replacement reaction, except instead of having a single element, we have a switching of one of the ions in two compounds. So let me go ahead and give you a definition of that, and then I will show you an example with alphabet letters, and then we'll actually see a classic type of reaction. So with a double replacement reaction, we have two ionic compounds. You remember, an ionic compound has a positive ion and it has a negative ion. So what happens is we have two ionic substances, and they each have a positive ion and negative ion, and they're switching the positive ions. They switch the positive ions. So let's take a look at what this might look like with alphabet letters. So we've had A and B, C and D, E, F, and G. So we're going to use H and I. So it's a mythical compound called HI. And we're going to be combining that with another mythical compound, JK. Okay, and these are ionic compounds with a positive and negative, and the positive ion is first, the negative ion is second, the positive ion is first, and the negative ion is second. So again, look at what we're starting with, comparing this to a single replacement reaction. Here is a single element with some type of compound, and here we have two compounds that are going to be switching their positive ions. So these two are going to be switching places, the H and the J and the H are going to be switching places. So when those switch places, let's see what we would get. If the H comes in and kicks out the J, we form a new compound. The H kicks out the J, we're going to form HK. And if the J comes in and kicks out the H, we're going to form JI. Again, it's a positive and negative, and a positive and a negative. An example of that is taking a compound called sodium carbonate. It's Na2CO3. We can mix this with the second compound, which is calcium chloride. And what this is going to do is it's going to produce, well, let's see, we're going to be switching the Na and the Ca, and the Ca and the Na. So when the Na comes in, we're going to ignore the subscripts here, but when the Na comes in, it's going to bump out the Ca, and it's going to create NaCl. Now the Ca has been kicked out, and it's going to then kick out the Na over here and switch places, and this is going to form CaCO3. So again, we're switching those positive ions. Here the H and the J are switching. Okay, here the Na and the Ca are switching. Here's the positive ion, here's the positive ion, and we're just switching those ions. Now we want to balance this, and notice how I have two Nas over here, I only have one Na over here. So I can't put a subscript down there, I actually have to use the coefficient, and so it's going to form two Nas and 2 Cls. And notice over here, this has 2 Cls as well. It has 1 Ca, and it has 1 C and 3 Os, and 3 Os right there. So this is now balanced just by putting that 2 as a coefficient in front. So what this forms is actually a substance which is called chalk right here. So now think of this reaction. If we combine sodium carbonate and calcium chloride, that's the name of the two starting substances, we end up with salt. Well, what happens to salt in water? Salt is going to dissolve, and it's going to stay dissolved. But this over here, this is calcium carbonate. This is called chalk. Chalk does not dissolve in water, and so this stays a solid. And so that's one other feature of a double replacement reaction is you can mix 2 liquids together and you'll get 1 solid out of that combination. And we'll have a lab showing double replacement reactions, and we're going to be getting some solids, and then we'll be finding the formulas of those solids as well. So that's the 4th reaction, and that's a double replacement reaction. And the last reaction is going to be a combustion reaction. In a combustion reaction, something's going to combust. We have a combustion engine which powers our car. And in combustion reactions, we're burning something. We're burning a fuel, and we always burn that fuel in oxygen. So in order to burn something, you have to have oxygen. If it's a piece of paper, you have to have oxygen. If it's the candle in the jar, if you put the jar on top of the candle, it's going to run out of the oxygen. Oxygen is required in order to burn things. So let's go over a reaction, and we're going to be looking at methane. Again, this is the natural gas that comes from the pipes in the classroom, and we're going to be burning this in oxygen, O2. So it's going to produce the products of water and carbon dioxide. This is a hard reaction to balance because if you notice we have oxygen in one compound here, we have oxygen in the 2 compounds over here. So here's the methane. Methane's also called natural gas. This arrow means that a reaction is going to be taking place. This is the burning process. And we're going to produce water and carbon dioxide. Also, we're going to produce lots of heat as well as part of the reaction. Let's see, we have 1 carbon here, we have 1 carbon here. We have 4 hydrogens. We have 2 over here. This is going to require us to have 2 of these. So now 2 times 2 hydrogens. If I have 2 waters, each water has 2 hydrogens. 2 times 2 will give me 4. But it also multiplies the oxygen by 2 as well. So I have H2O. Each water has 1. 2 times 1 gives me 2. So now I have 2 oxygens from the water and 2 oxygens from the carbon dioxide. 2 plus 2 gives me 4. So 2 times what for the oxygen will give me 4, and it's going to be 2. So here's the balanced reaction for a combustion reaction. And in our lab, we will also have a combustion reaction, and we'll be balancing that and seeing the end products of that as well.